welcome to this video on standard deviation. So, standard deviation is probably something that you haven't seen before, but what standard deviation actually does is help measure spread of the data, and we would expect things to lie within certain amount of standard deviations from the mean. What we've got here is the formula that we can use. So we've got S here as being standard deviation, and it's equal to the square root of all of this. Now, this funny looking symbol here that looks a little bit like an E is actually sum. So it's the sum of these bits here, where X with a line over the top is our mean, so we have to actually calculate the mean first. X here is a value in our data set. N is the number of data points, or points of data, so in this case here we've got 6 of them, and minus 1. So let's look at this set of data here. What we're going to do is, first of all, we're going to have to find the mean of this set of data. Then we're going to find its standard deviation. So the mean of the set of data here is, we'll just add them all up and divide by how many there are. And in this case, it equals, so I'm going to go X with a line over the top, that's going to equal 8. Double check it if you like, so 7, add them all up, that's what you get. Next, what we need to do is for each set of the data points, find out what the X minus the mean squared is. So for 7, so let's draw up a little table. We're going to go X, and we're going to have X minus the mean squared. So we've got 7. So 7 take 8, because 7 take the mean. So 7 take 8, which is minus 1. Minus 1 squared is 1. 11 take 8 is 3. So let's put 11 here. 3 squared is 9. 8 take 8 is 0. So 0 squared is also 0. 2 take 8 is minus 6. Minus 6 squared is 36. 15 take 8 is going to be 7. 7 squared is 49. And 2 take 8 is minus 3. Actually, this shouldn't be a 2. That should actually be a 5. So I'd apologise about that. So 5 take 8 is minus 3. Minus 3 squared is also 9. Now, the values here, I actually have to add them all up afterwards, but these values in here must be positive. Alright. So if we add all of these up, we'll end up with 104. So where does this 104 actually play a part in it? Well, the 104 is actually this bit in here. So what we've done, we've had the sum of all of these values here. So now if we plug the value of 104 into this formula, what we're going to get is our standard deviation. So let's go. Standard deviation is going to be equal to 104 divided by n minus 1. So there's 1, 2, 3, 4, 5, 6 points. 6 minus 1, which is 5. It's going to be the square root of that. Now, if we plug that into our calculator, we're going to have the standard deviation as roughly being equal to 4.56. So that means that the mean of the data is 8. We'd expect that the majority of the data is going to lie within plus or minus 2 standard deviations of our mean. We can also use technology to do this, and this is something I will show you guys in class how to do on your calculators, because it can make it a lot simpler than trying to add up all of the values for this part here. If we have a lot larger data, then it's going to be a lot harder to do it. But on our calculators, we can just plug the values in and go for it. That's pretty much it for the standard deviation. And that's that basic formula. That's really what it means. Probably the trickiest bit is to knowing what the part in here means. But once you've got that, it's pretty simple to use. And as I mentioned, our calculators are going to give us some more information as well, and it's going to be a lot quicker. So hopefully you've enjoyed this short little video on standard deviation and how we use this lovely formula to calculate it. Don't stress if it's the first time you've seen it or seen anything like it, especially this sum sign here. You guys may or may not have come across that before. If you've got any questions, just come and ask. And as always, thanks for watching, and we'll see you next time. Bye for now.